let's record this. Okay, so as usual, we're going to have to find a value over here that when multiplied to 2x gives you negative x cubed. What is a good suggestion that we can have? What should we multiply to 2x in order to get negative x cubed? Okay, let's try. Negative half x squared. For those of you who got it correct, got this question correct, is this how you start off? Oh, okay, sorry, my mistake. Negative half x squared. So for those of you who got it correct, is this how you started? For algebra, the convention, the norm is we use fractions, specifically improper fractions. We don't use mixed fractions in algebra. We don't use decimals in algebra. Only in rare cases. By default, we shall use improper fractions, okay? So just remember that. Is there any other person who got the correct answer but did not start this way? Anybody? Okay, who got the correct answer and started off this way? Raise your hand. Can I take a look? Okay, yeah, this is the way that we can do this. So let's multiply them down. I will get negative x cubed. Then negative half x squared minus times negative 1, we get positive half x squared. So the subsequent steps are all the same. Okay, 7 minus half. We get 6.5, which is actually 13 over 2x squared minus 4. So we need something multiplied by 2x to get 13 over 2x squared. What will that be? What would that be? What is the unknown over here? 13 over 4? Is it a plus or minus? Okay, plus 13 over 4x. Right, so let's multiply them together. We get 13 over 2x squared minus 13 over 4x. Subtract it away. Naturally, we are not going to get any more x squared terms. Negative 4 plus 13 over 4x. I believe you can continue by yourself already. Yes? Okay, so this is a variation of the question where you are expected to be able to identify these fractions over here. Okay? So I shall not finish it for you. Then yesterday we started on remainder theorem. Okay? I didn't formally introduce it to you yet, but let's see what we obtain. Okay. So this was what we had. This is my polynomial, my dividend. Okay? It's equal to the divisor. We are dividing by x plus 2. Then we will get a quotient and we will get a remainder. Okay, so this is for the example in, I think one of the first few ones. Work example 8 if I'm not wrong. Yeah, work example number 8. Then we realize, let's do a quick recap. All polynomials can be divided by a linear factor like this. I say linear because power is 1 only. The degree of x is 1. When you divide it by a divisor like this, I will definitely get a quotient that when multiplied together with the divisor plus the remainder gives me my original polynomial. And we saw that from examples like this. Okay, so we are building on our primary school knowledge. Okay, then we learned that, hey, if I only want my remainder, I can substitute values of x such that all this will become 0. Then my quotient will become 0. Regardless of what my quotient is, when multiplied to 0, it will disappear. Therefore, leaving me only with the remainder. In this way, I do not need to go through the whole process of long division to find out what the quotient is, to find out what the remainder is. And I believe you also agree with me that less room for careless mistakes. Okay, so the approach is going to be like this. Okay, the question is going to be, I want you to find the remainder. Find remainder when 4x cubed minus 8x squared plus 9x minus 5 is divided by x plus 2. Okay, so this is now going to be my question in red. Keeping this in mind, to find the remainder is really easy. Let me show you the steps. So this is what we write. Let px, okay, now we are bringing functions back. Let px be equals to 4x cubed minus 8x squared plus 9x minus 5. Okay, when I let px be something, naturally I'm going to be replacing values of x. That is the reason why I want to write it this way. So remainder, straight away I can tell, is equals to p. What should I substitute for x? What is the value of x I should substitute such that all this becomes 0? Negative 2. You are absolutely right. And where did we get negative 2? From the question. This is the question. Where did I get the negative 2 from? The x plus 2, right? We know that the choice for the value of x came from the factor or the dividend. We are going to decide, we're going to let x be equals to negative 2. We decided it is going to be negative 2 based on the polynomial 4x cubed minus blah, 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 or did it come from x plus 2? Where did it come from? The value of minus 2. It came from the factor. Okay? It came from this x plus 2. What exactly did I do? How do I generate this x equals to negative 2 from the factor? Okay, do you understand my question? Once the factor is equals to 0, I multiply by the quotient, it will be 0 and I'm left with the remainder. Make sense? So, I let this be equal to 0. Therefore, in my mind, I know x equals to negative 2. That is why I put x equals to, I substitute the value of negative 2 here. Okay, do I need to write down, let x plus 2 equal to 0, x equals negative 2? No need, this is A maths. You are expected to be able to look at this. Look at the factor. Oh, factor is x plus 2. I must sub x equals to negative 2 in order to find the remainder. So that's it. Here we will therefore have 4 times negative 2 power 3 minus 8 negative 2 power 2 plus 9 negative 2 minus 5 equals to answer. This will give you 1 mark. This will give you 1 mark. Easy? Very easy 2 marks given to you. Yeah? Okay, or if you are a bit more stingy, then it will be just 1 mark lah, because it's too easy already. Alright? So let's try an example. Practice now. 8. Find the remainder when 3x cubed minus 4x squared minus 5 is divided by part A, x minus 2. So the steps are, let px be equals to 3x cubed minus 4x squared minus 5. Remainder is equals to p, put in the value, substitute in, and get the answer. 2, and what do you say the answer was again? 3, I'm not going to check over. Okay, now part B. How should we find the remainder? Remainder. Presentation is important, okay? For A maths, what should I write? Remainder equals to P. Can I use P again? Yes, right? I defined it earlier already. Let P equal to this. So I'll continue using it. So you see, in this way, it is very convenient. Remainder will therefore be P equals, P, x equals to? What's the value of x? Negative 5. Substitute in. 3, negative 5, cube minus 4, negative 5, square minus 5. What's the answer? Negative? 408. 480. Is this the correct answer at the back? You must check your answer at the back. Okay, very good. So you see, instead of writing when x equals to -5, I can simply write p bracket -5. Okay? Now let's do part C. Slightly more different, slightly more challenging. But the approach is still the same. Remainder equals to p. What should I substitute in? 3/2. So again, we prefer to use mixed improper fractions. So how do you look at this and say it should be x equals to 3/2? In our mind, we should be letting the factor be equal to 0. 2x minus 3. Okay, I shouldn't say factor. We should let the divisor be equal to 0. Because that's our whole aim. I want the divisor to be 0 so that when it is multiplied by quotient, it will still be 0, leaving me with the remainder. So x equals to 3/2. Substitute it inside here. Okay, so again, 3/2 cube minus 4, 3/2 square minus 5. Answer. Always show this step. Show the substitution. Show what you substitute in. And what's the answer? -31 over 8. Is it the correct answer? At the back? Okay, very good. Okay. All cool with this? Yes. Why do we need to know the long division? Because I'll give you a question that asks you to use long division. I'll see whether you know how to do it or not. And there will be other situations where I don't explicitly say it, but you will be required to use long division. Later on, as we go through more questions, you'll see when. When does that happen, okay? So you cannot throw away your long division, you still need to use it. Let's take a look at work example number 9. Finding an unknown using the remainder theorem. This is another type of question. All the work examples, they have something to introduce to you, a new type of question to introduce to you. So we want to find the value of k if there's this polynomial, it has a remainder of 12 and it is divided by x plus 1. Let's read the question first. Do you really understand the question? Do you understand what they are trying to say before we tackle it? Okay, so again, I'll let px. Notice in the solution in our textbook, they say let fx. Doesn't matter. P, F, they're just letters. Let px be equal to the polynomial 4x to the power 7 plus 5x cubed minus 2k. There's an unknown over here. X squared plus 7. Oh, unknown again, minus 4. This is my polynomial. I know that it has a remainder of 12 when it is divided by x plus 1. What does that imply? Remainder of 12 when divided by x plus 1. Can I form an equation? Yes. What is the equation? Okay, different ways of writing it. I prefer to start with px, okay? So p, what is the value of x? Okay, p -1. Yes, you let the divisor be equal to 0. P -1, what is it supposed to be? What is it supposed to be? The value. What is the value supposed to be? 12. The moment you write this down, you get 1 mark. Okay? Easy, right? Yeah, depend on the marking scheme lah. But this is what we want. This is what you need to be able to show us. When x equals to -1, I will get a remainder of 12. Is it very easy from here on? Do you know what to do with the -1? What should we do with the -1? Sub in. So this implies, this arrow over here, don't anyhow use it. This symbol refers to therefore. It means so. It means this implies that. Okay? So there is a meaning to this symbol over here. Therefore, 4 -1 power 7 plus 5 -1 power 3 minus 2k. That is an unknown over there. -1 squared plus 7k minus 4. Oh, what is this supposed to be equal to? 12. Can solve? I'm sure you can do it. There's only one unknown. Solve for k. So now, practice now 9. How long do you think you need for question 1? How long do you think you need? 3 minutes. So until 8:29 lah. First we let Px be equal to the dividend. Then I sub x equals to 1 because when it is divided by x minus 1 we have a remainder of 9. So this statement tells the marker that when Px divided by x minus 1 remainder equals to 9. Okay, this part tells the marker that you know this, I know this. So you substitute 1 inside, it is very trivial, it's very straightforward. I don't even bother to write down 4 times 1 cubed plus a times 1 square. Simply just write down 4 plus a plus b plus 3 equals to 9, forming an equation. Make one of the unknowns the subject. I'm going to use substitution. So here I've got my equation number 1. Then I do the next substitution. Okay, when it is divided by x plus 3, I get a remainder of negative 27. Do all your substitution again. Get another equation. Equation number 2. Of course, we are expecting 2 unknowns with 2 equations. Otherwise, I cannot solve. Okay? If you have 2 unknowns, minimum you must have 2 equations. So sub 1 into 2, everything else is just your simultaneous equation already. Okay, do it carefully. B equals to negative 5, A equals to 7. Okay? For those of you who did not manage to get the answer, you need to differentiate whether it is a concept problem or careless mistake. I would like to think that it's just careless mistakes lah, because it seems like most of you already understood how to use our remainder theorem. Okay? Okay. So that's all for this part, and this is our homework due on Tuesday. Exercise 1C, please copy this down. 100 divided by, let's say, 5. What will happen? Okay, let's work this out. 1 cannot divide by 5. 10 divided by 5, we get 2. 10. Okay, we all know that it's going to be 20 lah, right? Is that a remainder? So we can therefore write that 100 equals to 5 times 20, where 5 is the divisor. This will be my quotient, right? Is there another name for this 5 over here? It starts with F. Factor, yes. How do you know that something is a factor of something? How do we know that something is a factor of something? When there's no remainder. In other words, remainder equals to 0. Okay. Look at this. If I divide px by dx, then it so happened that rx equals to 0. What can you conclude about dx? Use, okay, one more time. If I divide px by dx, I do a division, then I realize, actually there's no remainder. What can you conclude about this dx over here? It is a factor of px. Yeah, okay, this is the new theorem, factor theorem. We have learned remainder theorem, we have now learned factor theorem. Is it logical? If our conclusion if remainder equals to 0, then the divisor is actually a factor of px. Okay, we see how we can use that, okay? So 1.4, factor theorem. Okay, let's take a look at work example number 10. Find the value of k for which x minus 2 is a factor. So I'll just write down these key phrases. X minus 2 is a factor of fx. Okay, digest it. X minus 2 is a factor of fx. X minus 2 is a factor of fx. What does that tell me about the remainder? Okay, this must be your train of thought. Okay, x minus 2 is a factor of fx. Therefore, remainder equals to 0 when x equals to Come on. Are you sure it's 2? Think about it. X minus 2 is a factor of fx, okay? It means that a remainder is equal to 0. And the remainder is equal to 0 when x is equal to 2. Yeah, you're right. Do you know why? We are still using the same remainder theorem. Your factor theorem is a special case of your remainder theorem. Okay? Recall our remainder theorem. Theorem tells us that if I want the remainder equals to p and then a certain value of x, okay, this value is dependent on the divisor, okay, and then our divisor usually looks like this, divisor. It looks like this, x minus question mark. Usually looks like this, x minus something or x plus something. And then we know that, we need to set this to be equal to 0. Then I find the value of x to substitute inside here to get my remainder, correct? Yeah. Now, my factor theorem simply says that, when this happens, the remainder is 0. Okay? And the remainder is 0 when, the same reason, this divisor over here must be equal to 0. When this is equal to 0, x is equal to 2. Agree? So, when x is equal to 2, then my divisor becomes 0, right? Divisor 0 times quotient, what do we get? 0. Then we are left with the remainder, right? How much is the remainder? 0, yeah. That's the whole idea. Let me put it down in the form that we are all very familiar with. So, px equals to dx times qx plus rx. Now this time, let us do some quick substitution. My dx, the divisor, is supposed to be x minus 2, right? We are dividing by x minus 2. What did they tell us about px? What is the value? What is the px? Oh, they used fx, but so this is fx. What did the question say it is? It is actually, let me substitute 3x cubed minus 2x squared plus 5x plus k. Okay, this is supposed to be equal, right? Left hand side equal to right hand side. Alright? One extra info they gave you. They give you that this is a factor. This is a factor. Is a factor of fx. This implies that Rx equals to, yes, it is equal to 0. This is equal to 0. Okay? And do you remember how we got our remainder from our remainder theorem? How did we use to get our remainder from our remainder theorem? We make the divisor 0. Same approach. I make the divisor 0. When x minus 2 is 0, what do we have for x? 2. So, I'm going to make x equals to 2. Okay? Let me write it down in words. When x equals to 2, x minus 2 equals to 0. This is my divisor. Right? And I know that Rx will be equal to 0 because it is a factor. There cannot be a remainder. What does this all mean now? What does this all mean? It means that when I sub x equals to 2, this becomes 0, this becomes 0, this must be 0. Okay? In summary, factor theorem. Okay, fx, this time when I sub x equals to 2, I will get 0. Normally, when I sub 2 inside, I should get a remainder, right? When I sub the value 2 inside the function, I should get a remainder, isn't it? Normally, I should, yes. But this time, what is the remainder? 0. That's why we have this. Because it is a factor. Remainder is 0. Okay, I'm repeating the same phrases over and over again, so that you can remember it. So let us substitute now. 3 times 2 to the power of 3 minus 2 times 3 square plus 5 times 3. Wait, why am I writing 3? 2, 2. 5 times 2 plus k equals to 0. Can solve for k? Yeah, k equals to whatever it is. Negative 26. Okay? Let's do simple questions. Well, this one, 1 mark. You show me that, hey, actually when I sub x equals to 2, remainder is 0, I give you 1 mark. Provided it is a 2 mark question. No need. Like I said, we look at dividing by x minus 2, we are expected to be able to tell that we should sub x equals to 2. Okay? So let's practice. We've got exercise 1D. Let's do question 1A, okay? Exercise 1D, question 1A. This is not a homework question, it's just a practice. Not a homework question, just practice only. X minus 1 is a factor of so and so. Find the value of k. Step 1. Let, you want px or you want fx? Whatever I don't care. Px. Let px be equals to 3x cubed plus 7x squared minus kx plus 5. Then they tell you that, x minus 1 is a factor. It is a factor. What is the remainder? 0. So if I try and use my remainder theorem, this is what I'll write. P, what do I substitute for x? Yeah, I substitute 1. I expect the remainder to be 0. This special case of the remainder theorem, where the remainder is 0, is known as the factor theorem. Do we need to know all these names? Nah, I don't really need to know. You just need to know how to apply. Okay? So substitute 1. So it's so easy, right? 3 plus 7 minus k plus 5 equals to 0. K must be equals to 15. Done. Check the answer at the back. Yes. Okay, so this is the solution for 1A. Let's do 1D.